This is the video for page 294 through 297, exercise set 6.5, exercises 5, 11, 14, and 17. All four of those are distance, rate, time problems, and they are all solved in a similar manner, so let's go through them all together. The first thing we need to do is get some information up here in the right hand corner where we're going to put our little toolkit, our conceptual toolkit. We know that the rate, and we're talking about the rate of speed here, is typically defined as things like kilometers per hour or meters per second or miles per hour or what have you. And what we've got when we say this sort of thing is we've got r, the rate, equals distance divided by the time. So r equals d over t. If we multiply both sides of this equation by t, we can see that the rate times the distance will, the rate times the time will equal our distance. And if we divide both sides of that by r, we'll say that the time equals the distance over the rate. And the reason I'm putting this all over here, and I'm going to put a little box around that so I can refer to the blue box. Knowing these formulas and knowing the way that they interact with one another will allow us to determine how to build the equations to solve these problems. So let's look first at exercise number 5. Exercise number 5 says a boat takes an hour longer to go 36 kilometers up a river than to go down a river, and if the boat travels 15 kilometers an hour in still water, what's the speed of the current? Well, that looks horrendously complicated. I can't put that anywhere. I'll put that right there. Go right here for now. There we go. So a boat takes longer to go up the river than it goes down the river. So what it tells us is that there's a difference in time. That's the first thing to answer. What's the difference that it's giving us? It's giving us a difference of 1 hour, whether it's going up or down. So we can say that the time up the river minus the time down the river equals 1 hour. That's the difference. Remember that the time down the river is a smaller amount, it's a shorter period of time than the time up the river. So given that, we can look over at our equations here and say, well, which one talks about time? Well, this one does. Time equals distance over rate. So we can say that the distance up the river, well, actually we know what the distance is. The distance over time, distance over rate, distance over rate up the river minus the distance over rate down the river equals 1. Time up minus time down equals 1. If time is distance over rate, then the distance up minus the distance down equals 1 as well. So the distance up, the distance down is the same. It's 36 kilometers up, it's 36 kilometers down. So on the bottom side of these equations here, the rate up the river is going to be, well, it's 15 kilometers an hour in still water, so the rate up is going to be 15 kilometers minus the speed of the current. And the rate down is going to be 15 kilometers plus the speed of the current because we get that extra kick. And that's the equation that needs to be solved using your algebra skills to solve number 5. For number 11, number 11 asks, or it says, that James drives 300 kilometers. If he increases his speed by 10 kilometers, it takes 1 hour less time. Find James's original speed. So what does it give us the difference in? It gives us the difference in time. It's going to be an hour less time. So it's the same thing again as what we just saw. We've got the time, we'll call it time slow, and we've got time fast. So his slow time, which is a longer period of time when he's driving slow, is an hour more than his fast time. So if we subtract the fast time from the slow time, we should get 1 hour. And so once again, we look at our little toolkit up here and we see that time is distance over rate. So once again, we'll go distance over rate slow minus distance over rate fast equals 1 hour. And it says that the 300 kilometer distance divided by his slow rate, we'll just call that R, minus the 300 kilometers over his fast rate, which is R plus 10, he's going 10 kilometers an hour faster, is going to equal 1. And we solve for R, and that's our answer. We'll do a separate video for the other two.